Hello, and welcome back to another episode of Manufacturing Tomorrow's Workforce. I'm Amanda Del Buono. For today's episode, I'm joined by Russ Rhinehart, a columnist for Control Magazine, engineering coach and professor at Oklahoma State University's School of Chemical Engineering. Russ left his career in industry to move into education and help fix the academic practice gap. In fact, Russ is currently calling for process control professionals to share their thoughts on how students can be better prepared for the process control industry. The International Federation of Automatic Control Education survey goal is to help align process control education and practice. Russ has also written several Develop Your Potential columns in Control Magazine on the topic, including a piece in February 2019 titled Understanding the Rationale Behind the Academic Practice Gap, which is available on controlglobal.com, and you can find the link in the show notes of this episode. Russ, thank you so much for joining me today. I'm excited to have you on after reading all of your workforce pieces in Control.
Thanks, Amanda. I'm looking forward to the discussion. This is an important topic for me, and I greatly appreciate you guys inviting me.
Absolutely. So just to get started, I understand that you left the process control industry for academia. What were you seeing in industry that sparked your desire to make that switch, and what were you hoping to accomplish?
I worked 13 years for chemical manufacturing in a variety of different jobs. I really enjoyed working in industry, making things happen. I was in process development and product development and then eventually manufacturing. They promoted me. And that got me to realize how important it was to bring new hires up to speed, to help them through the transition of being a student. And I had to go myself through that transition, and I feel that it took me about 2 years to catch on when I first started as an engineer. And so I took on the job of coaching about 6 new hires in our overall department. I had one of them, but the others were in other groups, to try to accelerate the transition, to make them more productive, faster starters for the company. I really enjoyed coaching people through the transition, and I said, well, this is sort of like teaching. I also had ideas for how to use models for control in automated methods. This was back in the 70s and 80s, and I had just bought a home computer, a TRS-80 color computer for my kids to play on, and I was doing more complicated things on my computer than our controllers were, and I thought, well, we could do that. So for those 2 reasons, I left industry to become a college professor, to pursue improving education in the preparing students for the transition, and also to explore process control.
So you kind of glossed over it a little bit, but what would you say is the skills gap? What do you most prominently see when it comes to the gap? Is it certain soft skills or technical skills, or are these just skills that are learned through experience?
Well, it's all for sure. Anytime a person in industry changes their job function, they have to learn a lot of new skills. They have to learn a lot of new people. But there's still the way of industry, and that's very different from the way of being a student. You become successful as a student by memorizing everything the professor told you to memorize and regurgitating it back on tests, by being able to learn isolated things, not things in context, by learning, not doing. And so there's also the youth community that students are in. And within the youth community, they can be rascally contestants with each other because they're all peers, and there's no consequences of the community. There might be consequences to the student if they don't study and get good grades on the test, but there's no consequences to the whole community. So there's a lot of big changes in transitioning from being a student where the job is learning in a youth perspective environment to working in a professional environment where there are big consequences, and your job isn't to learn. Your job is to make things happen for the better. And because the students are programmed for 12 years through high school and then another 4 years, maybe 5 years in college, they're programmed to be in that youth student environment. They have to change their way of being. So it's not so much the technical skills, but they have to learn technical skills, or the soft skills, but they have to learn soft skills. We all have to continually learn as we transition functions. But it's really this perspective that students have about life, about how to be, that was shaped by education, that they need to set aside and adopt a new way of being, a new way of looking at life, a new perspective. So I think the gap is not so much on the skills as it is on the way of being.
Right, so moving from being a student to an actual practitioner then.
Yes, yes.
So what is the impact of the gap? What kind of impact is it having on industry?
So we graduate maybe 120,000 engineers in the U.S. every year, colleges, universities, 120,000 students. About 80% of them eventually go to industry. Some of them go to medical school or music school or law school or do something else, but eventually about 80% of those end up being hired in industry. And so if it takes 2 years for a person to catch on, to become fully, to shed their student perspectives, to become professional perspectives, and if that perspective change has about a 20% reduction in productivity because of the incomplete perspective, the extra coaching that they need, the things that they misdirect their time on, and if you multiply all of that times maybe the cost of a 1 year salary of an engineer to industry, $150,000 when you include overhead and benefits and things like that, I come out with $3 billion a year in lost productivity because of the gap, because of the transition, because of students not getting it when they move from school to industry because of the time it takes them to do it. So I'm looking at the impact as maybe on the order of $1 billion a year. And whether you you say 70% of the students, or whether you say it's 80%, or whether you say we have a 20% loss in productivity, or a 40% loss in productivity, or a 10% loss in productivity, it doesn't matter. It's a huge number. And that's per year to the U.S. economy with engineers. But I'll tell you that the gap, complaints about the gap are the same in nursing, healthcare, accounting, psychologists, education. When we prepare people to be teachers in elementary, junior, and high school, the students that start their careers teaching say the same thing. So the gap is a lot larger than just engineering. It is part of how education prepares people for professional careers. But in engineering, it is maybe $1 billion or more a year in the U.S. as an impact.
So you kind of mentioned that there's this, transitional period of graduates learning, moving from being a student to being a practitioner. Are there any other main reasons that we have the gap? Is there anything that education could be doing to better prepare people for these transitions?
So I think the answer to both is yes. Some of the reasons for the gap. Let's consider education. The professor has 30, 50 people in the classroom. The professor needs to get them to learn. So the professor can't confuse them with complicated context in the business scenario and the people behind and the legal issues. So the professor focuses on the science fundamentals without the context. So in order for the students to learn quickly, to be able to grasp fundamental engineering science concepts, they're done in isolation, in idealization. And so we start people with the ideal gas law, and then after they get able to use it, we tell them that there's lots of other issues that need to be considered, but the complexities of condensation, dimerization, intermolecular forces is just really too complicated to learn quickly. And so often we just keep the ideal gas law and we send them on to the next level with that as the understanding. Professors need to grade lots of papers. We need to credential that the students are learning the material. And so you can't ask them complicated questions. You have to ask them very easy to grade questions, because the grading is usually done by a teaching assistant, not by the professor themselves. And the teaching assistants are master's students or PhD students that are just learning, that just came out of the undergraduate program themselves. And so the grading has to be multiple choice questions, fill in the blank questions, very simple calculations in order to show that the students have the basic concepts. And then you send them on to the next basic concepts. So I think in education, the environment for professionalism of the students is learning very elementary concepts in an isolated, idealized situation. When the students get out, it's a complex situation. There is no professor telling them. They have to learn things, but there's no professor telling them, did you learn it correctly? They have to test themselves, but we don't teach students to self-evaluate. We don't tell students, go learn this material and come back to me and demonstrate that you understand it. We create the questions, we tell them what to learn. And in industry, it's all self-guided learning and self-guided testing. And we don't prepare students for that. So there are lots of aspects of education that make learning efficient, that create an environment that does not prepare the students for what they have to do when they transition to professional practice.
Right. That's really interesting. And it kind of dovetails into what I wanted to ask you next. In your February column, you said, quote, if we want to change what is taught in the classroom, then we need to change the environment in which current practices have evolved. But then the instructional practices and faculty persona that have evolved academically would not be suitable. If we change the academic environment, the faculty members would have to evolve. Do we need a total evolution of education and in the way that our professors are teaching? And why?
I think we need a change. I would say a total evolution. The problem is, the saying is, don't throw out the baby with the bathwater. Make sure that when you're throwing away the bad, that you keep the good. So I think we have to be very careful about changing education. I think it does need to be changed. I'll also say that there are some professors that are very interested, that understand the practice and what the students are going to have to do at their next level, and understand the transition and help the students go through that transition. This often happens with the unit in chemical engineering, with the unit operations or the design classes. And sometimes the professors will bring in industry speakers for seminars to help prepare the students for what's coming next. I'll also say that there's some schools that are very practice-oriented that aren't getting their fame and fortune and reputation because of their PhD program and their research, but are trying to establish their reputation because they're preparing people for the practice. So the entire education system is not at fault. But I would say that the predominant values in education are to become a famous university through graduate research, through PhD research. In order to do this, we need funding for the graduate students and for the professors and for equipment. Most of the funding comes from science foundations, the National Science Foundation, the National Institute of Health, things like that. These are not industry practitioners' organizations that are shaping the funding, but they're scientists that are shaping the funding. So most of the professors are pursuing science research, not practice. Most of the professors come out of the PhD program, science research, and are hired so that they can bring in money to support famous graduate publications. So I think most of the academic criteria for success is misdirects what's being taught in the classroom. So I think we can do lots of things. I don't think we need a total evolution, because I think the graduate program and the research, the extension of knowledge into new areas that we do in the academic community is important for opening paths. So I think a lot of what we do in the graduate research is important, but certainly it is not supporting preparing people for practice careers.
Interesting. So we touched on education's role in this. So what role, if any, is industry playing in the academic practice gap? What are they doing to help or hinder?
I don't think the gap is industry's fault. I think industry has a different environment from the environment that academics have created to raise students in. And so, but industry is a customer. Industry hires the students, and I think industry needs to be a good customer. So if the supplier makes an off-spec product or a product that doesn't quite meet industry's needs, I think industry's role is to let the supplier know that they need an alternate attribute. They need different specifications on their product. So I think industry needs to be a good customer. One of the problems is that the funding for the universities is not through industry, it's through federal, state governments, science foundations that do the funding for the research, and for donations from major donors. And all of this is controlled by established academics, scientists. And so the control of all of the funding is not by industry people. The control of all of the funding is by people that are invested in the current academic structure. So I think the role of industry to help close the academic gap would be to collaborate in industry, professional industry societies, industry institutions, to send a strong message about the impact to the different agencies that are in charge of education. And this would include the accreditation boards, it would include the federal government and the state governments that dictate lots of funding, the boards of regents in the states. I think industry can influence by stating what the problem is, by stating what solutions might be, but they have to get the people in charge in order to make those changes. One of the issues is that the language is so different between the academics and the industry. When I left industry and started my career at Texas Tech University, I was there for 12 years before coming to become the head at Oklahoma State. Our industrial advisory board came to us and said, our students, when we graduate, they don't know how to communicate. Of course, when a professor writes a paper, the last thing they do in the paper is to put the conclusions. In industry, the first line you want to read is, what do we have to do about this? What's the conclusion? And so industry said, students don't know how to communicate. And the professors in the department said, you're right, we agree with you. They don't know how to communicate. We're going to fix this. We're going to send them to another English course. And so they added a technical writing course to the curriculum, which was taught by graduate students in the English department, supposedly teaching the engineering students how to communicate for industry. And of course, all they do is preserve the academic way of doing things. So just the word communicate, it means something very different in industry to how the academics interpret it. So I think it's not going to be an easy fix because our language is different, our understanding of the issues is different. So I think it's something we need to work on. And I think industry can be a good customer, but I don't think it's going to be an easy fix.
Right, interesting. Well, is there anything else that could be done or maybe should be done to improve communication and maybe cooperation between industry and academia to help fill the gap?
All engineering departments are required to have an industrial advisory board or some kind of feedback from the customer. And I think in the industrial advisory boards, industry, though my experience is that the industrial advisory boards are often led by the head of the academic department, not by the industrial advisory board. So I think it'd be nice to have the industrial advisory board have a larger collective voice feeding back as to what the issues are and how things could be fixed. But certainly industry hires students for co-ops, and some of the major industry players have summer schools for faculty to understand and learn issues like safety, design. So I think there's a lot of things that we could do. There's consortia of industry that support graduate programs. So I think there's a lot of things that industry is doing and can continue to do, supplying speakers for seminars and professional student group after school meetings where they bring in speakers, opening up their industry sites, their plants, their facilities for tours by students. So there's a lot of things that we can do that would help reveal the transition, the changes on it. So I think there's a lot of things we can do.
Well, is there anything else, any other tactics that you kind of see or ideas you have for how else we can fill this gap?
So I don't think we can ever fill the gap or close the gap. In lots of discussions about it, I know that one of my vice presidents when I first started working was invited by the American Chemical Society to talk about the transition, the gap. So that was back in 1969. So it's been going on and it's been recognized ever since. And I've been on a lot of society committees, and I don't think we can ever close the gap. I think for efficiency in education, you just have to teach a particular way. Students are going to be in the youth culture, but I think we can bridge the gap, narrow the gap by doing lots of things. And I think the main way to do it would be for industry to have a voice, a collective voice through industry societies, industry institutions, industry collaborations to the people who are in charge of education, the regents, the accreditation boards. You can't go back to the professor and say, here's a problem, I want you to teach differently. The professor's in an environment and they get rewarded for doing certain things. Demonstrating learning effectiveness with the students is one of them, but that's a very minor one. The way professors get rewarded, tenure, promotion, is through bringing in research funding and getting research papers published. So if you tell the professor you need to change what you're doing in the classroom, the professor's going to say, but that's not what my job description is. So you can't go back to the professor or the department head and say, make these changes. The department head is going to say, but the dean rates my department on how much money I come in. U.S. News and World Report rates our university by how much research funding we've come in. And so the whole game, the owners of the university systems have a set of rules, and we need to go to the very top state legislatures, U.S. government, the accreditation boards in order to get the criteria changed. So don't go back to the professor and say, you need to be teaching this in your classroom instead of that. That's not going to work.
Right. Well, you mentioned at the top how you worked with new hires when you were in industry to help them get up to speed. I'm presuming that's one great way for those in industry to kind of fill the gap within their organizations. But how would you suggest that industry managers train or better equip their staff that's struggling with the gap?
Students come out with fundamental skills, and I think most of what we teach in the university is relevant and useful. Looking back, there were a lot of courses I hated when I was at the university. English was one of them. But after graduating, I realized how important sentence structure was, transitions between sentences was, and even the poetry course, where I learned what metaphor was. Once I got out, I realized that I used metaphor constantly in trying to understand how molecules are behaving. So even the English courses, I felt, in retrospect, were very useful. So I think a lot of what we teach in the college is useful, but there's no way we can teach what every person needs for their 40-year career, technical career, and their 60-year after that lifetime, after college graduation. There's no way we can teach everything. So there's a lot of learning that has to happen. Some of the major industries have their own college, and they send people for their own internal training courses for a week every 6 months or so to learn the essentials that they need for that job. And I think that's important. But the gap that I'm talking about is not the technical knowledge gap, but it's the way gap. It's the way students are because of their environment and the transition they have to make to the new environment. So I think the best way to do this, and this is what I ended up doing when I was working for Celanese, is to have mentor-type programs. And as I said, I took on 6 of the new engineers, and every Friday afternoon for an hour, I would have a discussion group with them about these aspects of the transition as to what life was like different between the university, the freedom of a student in dressing the way they want to be or joking the way they want to be is different from what you're permitted to do in industry. So there's so much more than just the technical skills. It's the whole way of being. And I don't like the word maturity because it's not that the students are immature, but they just haven't made the transition to the professional world yet. And it's more than just professionalism. It is skills. It is soft skills. It's an awareness of what the criteria for performance is. There's a lot of it. So I think it's very important for industry to mentor new hires, to have a senior person or a first-line supervisor work with them. But it's not so much just getting the calculations right. It is the whole aspect of how do you be successful in industry. So I think not every first-line supervisor has the inclination, the understanding to do this. So I think industry needs to find people who are willing to be mentors and have them coach the new hires.
Well, it's great advice and overall some great insights. Russ, thank you again for joining us today and kind of filling us in on the academic practice gap, how we got here, and what we can do to maybe not get rid of it, but kind of shrink it if we can. It was a pleasure speaking.
Yeah, accelerate the transition or narrow the gap. Yes. And I think there's lots we can do. And I think it's important. I think it's a major impact on the U.S. economy. If you just look at engineers, and it is so much bigger than just engineers. It's education, academics in general. Anyway, I greatly appreciate the invitation, Amanda. This was fun for me, and I hope this message does some good.
I'm sure it will. Thank you again, and hopefully we won't have to keep on talking about this topic for too much longer, but if we still do, hopefully we'll have you on the show again soon. And thank you again to our listeners for tuning in today. Just a quick reminder to be sure to register for Smart Industry Base Camp, which will take place in Chicagoland March 30th through April 1st. You can register at event.smartindustry.com. Additionally, Influential Women in Manufacturing is still accepting nominations, so don't wait and nominate your colleagues now. You can do that at influentialwomeninmanufacturing.com. That's all for today, so be sure to like and follow Manufacturing Tomorrow's Workforce on Facebook and LinkedIn to join the conversation. Subscribe to Manufacturing Tomorrow's Workforce on your favorite podcasting app, and have a great rest of your day.